Well, hi there, boys and girls. Today we're going to take a look at some more transformations of our sine and cosine graph, and we're going to throw in what's called a phase shift. Now let's go through a general sinusoid, and we're going to pick out some things. First of all, if you have something added or subtracted, then we did this yesterday, then we know this is a vertical shift. We're just moving the graph up or down. If we have a number in front of the sine or cosine, this is called the amplitude. Then if we have a number in front of the x, and in our case it's going to have to be factored out of the parentheses because we're adding in this what's called a phase shift. This is how we find a period. So I'm going to write that 360 divided by b is equal to your period. You could also do the same thing in radians. 2 pi divided by the b is equal to the period. And the last thing we have here is something called a phase shift. And you know that that is in the parentheses, it works backwards of what you think. If it's minus c, we've actually moved it to the right. This is sometimes called a horizontal shift. So we're moving it right or left. So let's just get after this and do an example. Let's graph y equals 3 plus 2 sine 3x minus 60. And this is going to be in degrees. So here's the first thing that I'm going to do. I'm going to label some things. First of all, my vertical shift, I'm going to do VS, is up 3 because we've got the 3 plus. My amplitude is, I don't want to do arrow, that's not like up. My amplitude is equal to 2. It's that number. Now my period in degrees is 360 divided by that number b, which means I've got a period of 120 degrees. And then I also have a phase shift. My phase shift is right 60 degrees. So let me show you how to throw all of this together and graph this thing. First thing I want you to do is let's get an x and y axis here working. There we go. First thing I want you to do is draw, just like before, we're going to draw a dotted line at our sinusoidal axis, and that is up here at 3. This is going to be horizontally, this should be the very middle of your graph. Then from there I'm going to look at my amplitude. My amplitude is 2, which means we go up 2 and down 2, and that's going to be the very top and the very bottom of my graph. Now you have to look at your phase shift next, because this is like your beginning of your graph. That phase shift is right 60 degrees, so I'm going to go out here and I'm going to label that 60 degrees, and that's going to be the beginning. Then from there, I'm going to do one period, and this period should be 120 degrees. So from 60, that means I go all the way out to 60 plus 120, or 180 degrees. Then from there, you need to break 120 degrees up into 4 pieces, and that tells you where our critical points are going to be. They're going to go by 30 degrees. So I've got 60, 90, 120, 150, and 180. So I add 30 to my 60 until I get to 180, and let's see how this works now. This is a sine graph. Sine starts in the middle. So we go to our phase shift and we put a dot in the middle. Then sine goes up, back to the middle, down, and then back to the middle. Not too pretty because I didn't hit this dot, but please forgive me. So there is one picture of that graph. 3, and we went up 3, we went up and down 2 from there. We had a phase shift of right 60 degrees, so we came out here to the right, and then we did one full period from there. We broke it up into 4 pieces, and there's our graph. Let's take a look at another example. Let's do graph y equals 5 cosine of 3x minus, let's do 1 in radians, pi over 4. Now here, you're going to have to factor this 3 out and get it out of this parenthesis. So you need to, first of all, rewrite this as 5 cosine, factor the 3 out, which will leave me x minus pi over 12. So let's label some things about this. What is our vertical shift? Well, there is none, because I don't have a number in front like plus, like 1 plus or 2 plus. What is my amplitude? Well, my amplitude is 5. It's a number in front of the cosine. What is my period? Well, now I'm in radians because you can see my phase shift has radians. So my period is 2 pi divided by that number b, 2 pi over 3, which I want you to think about this for common denominators. That's the same thing as 8 pi over 12. You'll see why I need that when I graph it. Okay, and what about my phase shift? Well, my phase shift is right pi over 12. All right, let's see if we can do this. So there we got an axis. All right, the first thing I want to do is I want to look at the middle. What's the middle? I didn't move my sinusoidal axis anywhere, so my middle is just right here in the x-axis. Then let's do an amplitude. We go up from there 5 and then down from there to negative 5 because of my amplitude. Now let's do our phase shift. We went right pi over 12. And then from there we're going to do one period of the graph. One period of the graph is going to be, now our period is 8 pi over 12, but you start from pi over 12, so you have to add it to that. So that gets you to 9 pi over 12. Now why is that? That's because this pi has a 1 in front of it. So 1/12 pi plus 8 pi over 12 gives you 9 pi over 12. And so you see why I wanted common denominators. Now if you divide this by 4, you're going to get that we need to go by 2 pi over 12. So my next notch is going to be 3 pi over 12, and then 5 pi over 12, and then 7 pi over 12, and 9 pi over 12. So there we have it broken up. Now let's take a look at what we have. We have a cosine graph. A positive cosine graph starts from our phase shift of pi over 12 at the top, then it goes to the middle, and then to the bottom, and back to the middle, and back to the top. And so we do a little smooth little curve here. Harder to do than you think on my little air slate. There we go. And there's a picture of that graph. The tricky thing was we had to factor out that 3. And so we're going to practice this tomorrow in class, and I will see you then.